Yo. What's up, everybody? Welcome back. Today we are working on trying to make my image editor usable. We've been working on this image editor, right? And his goal is to replace both of my usage of GIMP and my usage of Paint. So often in the stream, we will, let's be careful here. New file. Let's, careful. Discard. Often we like open up Paint and we start like, just like jotting down random shit in here, right? We draw like some, maybe we'll draw like some diagrams. We'll be like, oh, we're working with memory, and like, oh, this stuff is used and this stuff is unused. We might do stuff like this. We might draw some trees, whatever. Um, and so this is kind of like the use case that I want to support in my image editor. And we do have the ability to do some stuff, right? We can open this guy. He's pretty quick to launch. You open him, he launches to a default canvas. And in here, you can start like drawing stuff. Wow, crazy. Here's our smiley face. And we even have some like nice little features that like color paint doesn't have. Like we can like adjust parameters of our brushes, you know, after we have written them. But we do not have the ability to work with this thing in any reasonable way, shape, or form. So one, if we have no eraser, so if I don't like this, I have like literally nothing I can do about it, right? I can't like even like draw white and then draw over top because that will change like all of the parameters everywhere. If I want to draw multicolor, I can't do that because like all again this adjusts everything written. So if I want to do something that's multiple color, what I actually do is I draw a new drawing on top and I say this new drawing is going to be the blue brush, right? And so like I have these brush parameters. If I want to change the red brush, I go back to the red layer where the blue stuff isn't like visible, and I like add stuff here, and then I go back to the blue layer and I add stuff on top. And if I want to like do like alternating red and blue, I'm like, probably like here, yeah, okay. Like this is stupid. This is like blatantly stupid, right? So I want something that has multiple brushes. I want to be able to erase things, and then often, like say we were trying to make like our thumbnail, right? And so our thumbnail typically has like our little icon in like the bottom right, and so how do we make that guy? Well, we make like a little circle and we color him black or something, which I should be able to type in numbers directly in here. I can't right now, but we make like a circle, and then usually like we draw a thing on this circle, right? So we make a new drawing, and then in here I go like, okay, let's make my the face for my guy, white or something. So we try to get to as close to white as possible, and then we like try to draw something. And if I don't like what I drew the first time, like I drew past the edge. What am I supposed to do? It would be nice to be able to hit undo. That'd be kind of sick, but I can't do that, right? So these are kind of like the things that we need to make this usable. I think in terms of like the drawing view and in terms of like today's goal, I think that I'm going to leave undo out of scope and just say if we at least we could erase this thing, that would be pretty big in and of itself. So features I want we'll leave undo out of scope, but we'll say that we want to be able to use multiple brushes and erase. I think those are two like reasonable things to want from this thing. And so the reason I'm trying to think about both of these at once instead of just implementing one is because I think that like however we decide to like present this stuff is going to have like a pretty large effect on what we end up doing. So I think that we have to like understand the data format that is going to work for both and kind of tackle them both at once, even if we don't get the UI for everything in place. So background here is like the way this thing works is everything I draw on the screen is turned into like a distance field. And then what we can do is we can then create like different brushes that are like parameters of this thing, right? So if I want to, do just like a color thing, that's like an option. But say we wanted to do something like make a window into another image. We could do something that's like, here, if we open this guy up like this. You can do something like if we have maybe this picture and we draw a drawing, we say, let's make a sampling thing. So we're gonna like draw something on here with, some sort of like big width. And let's say that like the thing we draw is like a window into another world. So we can like present like another image here. Oh, fuck. That's broken. There's a bug there. There's like a dependency loop that's not detected there. That's not good. But let's try that again. So we make a drawing. We say that we want to use like the sampler one. We increase the width. We draw a window in here, and then we say sample from some other object. So sample from this image, right? And so here we can like start like drawing in some stuff from somewhere else. And the idea here is that like the brushes are completely like user definable programs. So they just work on this distance field. Oh fuck. Sorry, wrong one. Input image. No, brush. Here we go, distance field. So like this is what the program sees, and then the program converts that into something else by like doing some math on it, which is pretty sick. And so if we want to have multiple brushes, it's a little less clear what we should do here. By the way, this is why you can do like post adjustments of like width and stuff, right? So if we go back to like our default brush, this is the reason that you can do this, is because you kind of have like distance at every pixel on the screen relative to where you like initially clicked, right? Which is like something that I would like to keep. I like the idea of having this like distance field based thing, but it means that if we want to swap between brushes, I don't really know how that should behave, right? Because if we go back to like this distance field view, say I do like one stroke like this, and I do another stroke like this, well, what actually happens is like in here, you have like a distance field to everywhere that you drew. And so if you can't like color these lines necessarily, I don't think. Maybe you can. Yeah, maybe you could actually. I was going to say that you have to do this in layers, but I think you don't. You could imagine that each okay, so the way these like distance fields are generated, which is kind of fucking weird. But like we are abusing the like GPU's render pipeline to make these things. So there's kind of like, if you have like a point, like you have like this line between these 2 points, what we do is we make like a cone below this point and a cone below this point, and like a triangle tent, like a Toblerone bar that goes between these 2 points. And if you look at that from like above, the distance from the center of this line is like the depth, right? Because like if your slope is 1, right, like distance down and like distance away are the same, right? And what this allows us to do is it allows us to basically like resolve which points are closest by like overlapping these cones, right? So you have like cone 1, and you know, as you get like further and further away from the center, you get further down and down, right? But if you like duplicate this cone and move it over here, now you've kind of like created this thing where like your distance is going to go up and up and up and up, and then as soon as you hit the midpoint between these 2 points, it starts going down again, right? And so all of that to say, I think if you just colored these cones with the brush that they were made with, you are now getting the information of not only how close am I to something, but which thing am I closest to. I think that works. And so then all we have to do is like assign brush IDs to each of these cones. And then when we run the brush program, probably we just filter by brush ID, by like brush ID. I think that makes sense. So we'll write ideas. Brushes. So distance field generation will tie itself to brush IDs. Okay. That makes sense. So I read about something like that for selecting items in a 3D editor. Interesting. I think they usually just like raycast. I think that my guess for how they would do that is you would like project the world from like the camera that your screen has, and you would just like raycast to see which one you hit first. But maybe I'm wrong. Oh, where you like render items to an ID buffer? Yeah, you could do it that way, where each of these guys are like colored a different way, and you color the projection, and then you just click. We actually do that for in our editor for like compositions. So if we have like a composition that's made up of 3 elements, right? What we do is if I turn on this debug view, each of these like images are colored a different thing, right? So you can see like the green is like this picture and the blue is this picture, and on the border between them, they're like different colored, and we just kind of like pick whichever one we hit. But anyways, that's beside the point. Okay, so distance generation, field generation will tie itself to brush IDs. And then when we will run each brush program, filtered by its input ID or something. So that seems kind of reasonable. So that kind of solves the like, that solves how we will implement multiple brushes. It means that like strokes have to be, in terms of like data, are like strokes have to be per brush. The data needs to know which brush created each stroke. Maybe if we don't cover this part today, we should at least cover this, probably. And then in terms of like erasing is just like, I need to do some sort of like spatial lookup for which nodes were clicked, which nodes are under cursor. So like the data for this thing, before we generate this like distance field guy, he starts as like a series of points, right? We start with just like, I have a point here, I have a point here, I have a point here, and like you are going to take those points, turn those into the cones and shit, and then render the distance field. But before that, we just have a list of points. So probably on a race, we need to figure out which points are close by within some distance. Probably. Distance is probably related to like screen size. Probably if you zoom in, I would assume that that distance should be smaller. And then I guess also, if we can't just delete individual points, maybe, right? Like our points, well, I guess it depends on how evenly spaced these guys are. I guess if we assume that these guys are relatively close together, we can just find which points are close by and then like delete them. But if they're ever really far apart, then that would be a problem, because if we like try to erase in here, we'd have to like cut the line and like add some more points. But I think that the way our like storage mechanism works right now, it's like we sample the mouse every frame and we just like slap that shit in there. So we can probably work on purely points and not worry about big gaps. Okay. Yeah, okay, so we need, okay, that seems reasonable. That seems reasonable. So what are we going to do? We are going to add, so like make sure we need some sort of data format that supports both. We need to split data storage by brush ID. And for now, we don't necessarily have to do that part. We just have to know that that's what we're going to do later. Let's work on a race first. So if we work on a race, all we have to do is spatial lookup. Okay. What do we have right now? In our drawing, no, what do we call this thing? We call this thing a drawing object. So this guy has a series of strokes. Right, because that's how he determines like the start and end of a line. So as I like draw this, that's one stroke, that's another stroke, that's another stroke. Which seems fine. All we have to do then is add some form of like spatial lookup. We don't, technically right now, this structure is like binding a brush ID to a list of strokes, as well as like brush parameters, which is kind of what we'll want later anyways, for like multiple brushes. Okay, so for erase, literally all we have to do is do like distance field lookup. Add, or like distance based lookup. I think that's literally all we have to do. Then once we have that, we can delete nodes that are near mouse. And as long as the resolution of this distance lookup is like good enough, that should be fine. There are like intelligent structures for this type of thing, but I think that what we can do, is we can just make a grid. Boom, 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 boom. And as long as like this grid is like small enough, we can just like clear all points within the cell that we click on. I think that's probably like step one. So maybe we say we will generate grid. We will add points to grid as drawn. On removal, we will split strokes. Split strokes when cell clicked. And then that's probably fine. Add distance-based lookup. Delete those. Yeah. Split, remove strokes. Split/remove strokes when clicked. Okay. Cool. Which means that we probably also need like an eraser tool. Which for now, I will just bind to right click because I don't want to think about it. Yeah, so we need to clicked with right mouse button. All right, cool. I think I'm happy with that. I think that is a good enough plan for the day. So let's just get moving. So we need to find a grid size which we believe is sane. So the potential problem here is that like we are trading more memory for higher resolution. Yeah. Okay. So maybe we just start with like something that's like always 100 by 100 and then figure it out later. Maybe that's fine. We could maybe graduate to some sort of like more intelligent a more intelligent neighbor lookup later if it turns out that this is like too expensive and or too what's the word? Too expensive or not detailed enough. We can always jump there later. I guess a question that we could have is, do we want to store these things for the lifetime of the application, right? Really, we probably only need one erase buffer that is kind of like shared between all drawing objects. But maybe I will tackle that later as well. Just because like I don't really know where that lives. It could just live in like app. So on like our main app, we could have some form of like erase buffer. Okay. And if this thing is like relatively cheap to generate, like cheap enough, then we could actually like tie this to like view level, like zoom level and stuff. So I kind of like that. I kind of like that where we have some sort of like erase buffer that just kind of sits up here. Maybe this is like erase lookup. Okay. And I guess this probably comes from objects. So in here, or maybe like obj_mod. So nearby this like drawing object, can we just make like an erase? What do we call it? Erase lookup? Erase lookup. And this guy, like we said, is just going to be like a grid. And he's going to remember which points are in which thing. So he's going to have like, he has like a variable number of elements that can live in each section. We're going to be modifying that often. Okay, so maybe it's reasonable to be like, I'm going to have an array, probably the size of the grid, probably fixed. So maybe we have like cells is going to be like a list of array lists. And each of these is going to have some sort of like stroke point or like yeah, some sort of like drawing like point, I guess. Index. Drawing index. How's the zigging going? Pretty good. Pretty good. And I guess our like drawing index is going to be something that's like, which stroke am I in? And what point am I? Right? So it's like within a stroke you have many points. That seems reasonable to me. So now what we have to do is we have to like, when we enter a drawing, we have to construct this guy. I guess also we have, well, we kind of have like this guy's gonna live forever, actually. So he's gonna take in his general purpose allocator because he's going to be like managing these array lists. And he is going to be saying like width. We're going to hard code these for now, but we'll have to come back. We might want to like tune these later. Fix me unsure about grid size. Okay. Okay. So this guy on init, he's just going to be like, make me, first of all, my cells. So I'm going to make width times height of these, like, of these array lists. Boom. Okay. So this is cells, and we memset the cells to default initialized. That's part one. Why did you name the variable GPA? Maybe you'll pass something else. I think that I won't pass something else. This is like me saying, don't fucking pass something else. That's what I'm saying. Because like my application like will use arenas in a lot of places, and I'm like explicitly saying, don't fucking give me an arena because it will not do what you expect it to. Like it will not behave well. Yeah, that's kind of the intent there. Really, what I think I should do is in my like allocator module, I should strong type these things so I don't have to name them that way. But I haven't done that, and I don't know if I really want to. I think that would be like kind of a pain. Can you pass GPA type? I don't really have one, is the thing. Like my allocator, it was my custom allocator has a, he has like a tree of stuff where he can have, he's like page backed. He has like pages of memory that can back both an arena and a general purpose allocator, but these guys don't have like their own individual types right now. They could, but they don't. So there is no like strong type to pass in here right now. It is what it is. I agree though. It would be better. It was just like I didn't do that work. Okay. So this is simple. It's like GPA is equal to GPA and cells is equal to cells. Okay. So now what we need to do is we need some way to like initialize this guy based off of some drawing object. But maybe let's like, maybe first, can we like visualize the grid? That'd be kind of sick if we could look at it in some way. So let's kind of start here, where when we're in the drawing view, maybe we just draw which part of the grid I'm in. So like maybe we show where the mouse is hovering or something. So can we do like, I guess that's the responsibility of like the renderer. He is going to hold on to like the erase lookup. And yeah, okay. Sure. Then we're gonna have to figure out how to like render this thing in some way. Erase lookup comes from object mod erase lookup. But I guess before we get too into this, we should instantiate this thing. So erase lookup is equal to try erase init with probably something like this. Probably. I got this backwards. Okay. So now this works, and then when I construct the frame renderer here, I pass along this guy. So I say the erase lookup is an erase lookup, and this guy lives here somewhere. Okay. Let's chase some compiler errors. So this guy was the second last argument. And we'll just kind of do this a few times. I guess we can even look for this. Another one here. Another one here. This guy should be multiple lines. Another one here. And I think that's all of them. Do we file? We do. Hooray. Okay. So I think we shouldn't have done anything stupid. We should be chilling. Cool. Everything's working. We're back. Okay. So we have this guy. I would love to render him somehow. So maybe in our drawing view, somewhere we like render drawings. Somewhere. Drawing, here. So he renders this thing with the brush program, sure. Do I know where my mouse is in this guy? I do. I do know where my mouse is, and what unit is this in? Surely it's like object coordinates. Surely center. Yes. Maybe they're... Yeah, I think it is. Okay, so we have the mouse position. Can we start by just trying to like render, I don't know, something under the mouse just to make sure that we understand where it is? So how do we do that? How do we do that? I think we have like a constant color program somewhere. So our renderer can like create image render, background, path, comp, yeah. I think that we just make like a like cell hover is gonna be like we have like this type of program that needs to display, like, needs to be associated with some uniforms. So can I just be like void? There are none. I don't know if he's gonna allow that. And we need some sort of like fragment shader to go along with this side. So we'll just say like grid hover frag, I guess. Our grid hover fragment shader is gonna be something like blatantly stupid. I think it's literally just gonna be like render blue. So he's gonna be like maybe like reduced alpha at like blue. Sure. Sure. Surely. Which means that we can make a cell hover program that's stored here. And I think that he needs a buffer to go with this guy. Cell hover buffer. Yeah, that is full of these guys. It's fine. Okay, cool. We'll see how this works. Cell hover program is cell hover program, and then cell hover buffer is cell hover program make buffer. There we go. Okay, does that compile? No, because I can't enumerate this thing. So we need our uniforms to be like a list of we just need this to be like empty. Const null uniform is a structure, i.e. there's no program parameters for this thing. He just needs it to be a structure so that he can iterate the fields. Dumbass. Dumbass. Alright. Does that quell? No cell hover buffer? What do I call it? I fucking spelled it wrong? Okay. Yeah, this is just wrong. This shouldn't exist. We have no UV coordinates in this program, so they shouldn't be in there. Okay, cool. So we have a thing now that we can like try to render. So I guess we try to figure out where our mouse is. So we say like mouse position is going to like be on one of these grid cells, I guess. Seems reasonable to me. So this is going to come from like this width and height, I guess. Can maybe this guy says like, yeah, we're going to break this thing up into width and height, I guess. So we have like our mouse position X. This has got to be in like object coordinates. So this is going to be like something in -1 to 1, I assume. And we want to map this to 0 to 100. So I guess we just do that. We do like std math lerp. It's not that simple. So I guess we do +1 over 2 times 100. Cell X. This is backwards. We know where the mouse is already on the screen. And we want to convert that into cell locations. So it's like something that's like, I am in some cell. And I know that like this thing is in units of like 1 over 100 is like where these things will be apart. So I guess I just want to find like the floor and the ceiling of the cell I'm in. Yes. Yes, 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 yes. So I want to find how do I do that? How do I do that? I have mouse position in like -1 to 1. So I know that like my total range is like 2. And this is dispatched over 100 elements. Right? This is going to be like the cell, like cell width is going to be 2 over this. That makes sense to me. So this should give us like 2 over 100, 0.02. That makes sense. Okay. So then we just need to find where we are relative to this thing. So we do like cell x mod. We do our self mouse pause x mod this thing. Yes. And we go like lower x is like this is like distance into cell. Lower x is the mouse pause x minus distance into cell, and the upper is lower x plus cell width. Okay, yeah, so these are the bounds. Cool. So we can do the same thing for lower y. X distance into cell, y distance into cell. And we do this with y and height. And lower y is y minus y distance into cell. Okay. And then the center x is lower x plus cell width over 2. The center y is this. Yes. Okay. And then we just render a box there? Yeah, that seems reasonable. So it's like self render cell hover program. This actually shouldn't be. This should be like transform only. We do need to pass in the transform as part of this thing. How are we translating a full screen buffer into like a smaller section of the screen? So this is transform is going to be a mat 3x3. Yes. Yes, 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 yes. We're getting somewhere. We are getting somewhere. So now we just like compute the transform that basically takes something that where we have like a buffer that fills the whole screen. We want to like push that into like some small area. So we have the center of this thing. That's how we're going to move it. And then we're going to scale it first. So we're going to scale it so that the x scale is going to be cell width and the y scale is cell height. Yes. Okay. Seems reasonable. Then we translate it. By CX and CY. Yeah. Cool. So this is going to be the like cell transform. And we just render this thing with like transform is cell transform like this. And I think we need to render our buffer as well. Which is cell hover buffer or something. Nice. Nice. I think that like might work. This is 0 and 1 here, not x and y. Division by 0 here causes undefined behavior. 2.0, I guess. Because they kind of know. That's kind of sick that the compiler was like, yo, you can't fucking do that. Can I not do... Does this not autocast to a float here? That sucks. Can I do this? Really? Float from int? I thought this would work. I thought this would work. But fine. Fine. If you're gonna be like that. And then this is again 0 and 1 instead of x and y. Okay. All right, so we're going to drawing now. And we are seeing something, but it looks like we are not clamping this. It looks like the mouse position might be in like viewport space or something. No. Okay, so the mouse position is actually, we're drawing in the viewport, but we need to draw on the object. So we need to apply some additional transform to this thing. So this is the initial transform. We just forgot it. So let's try that. Okay, so we go new drawing. And now this guy, other way maybe? Maybe it's transform at the end, our input transform? Maybe? Maybe. There we go. It looks like it's the width and height of this thing is wrong. It looks like it's 2 times too big, which means we must have to divide by 2 here. Okay, new drawing. There we go. Nice. Okay, so we have our little cursor now to see how big this thing is. And now we can kind of like make a guess as to if we think that this is the right size after we start drawing some stuff. Why does this not work? Oh, because I have to write images here, even though there's none passed in. That's silly. Is software your job? Yeah, by some metric. Yeah, I mean, that's probably fine. Then when we erase this, we'll be erasing kind of like this. Yeah, I mean, that will be a little bit annoying, but not the end of the world. I can't see us wanting to be smaller than this. Yeah, that's good enough. Yeah, sure. Blaze it. Okay. Cool. Cool. So 100 by 100. Let's do a quick little calculation there on how that's 10,000 10,000 array lists, which is not that bad. That's fine. We can live with that. We can live with that. That's fine. Okay, so let's try to like classify. We need to like figure out which points are in the grid. So I guess like we'll say calc points or something, or like reset. Yeah, we'll reset this thing according to some drawing object. Okay. So what does he have to do? He has to iterate every single stroke and every single point. So you can go like for drawing strokes. So he's going to have like stroke and stroke ID here. And then he's going to iterate all the points. So this is going to be stroke points items here with, and he's going to be like point and point ID. And what's he going to do? He's going to be like, whoa. Oh yeah, so this should be vec2s. And these are in object space. So we do something that's like, we actually do something very similar to what we did in the renderer just now. These calculations are going to be the same, but they're not going to be about the mouse pause. They're going to be about the point that we're looking at. So, and I guess instead of being like which distance, we're trying to figure out which cell we are in. So still calculating the cell width and the cell height here is reasonable. These are like very like compile time knowable things. So width obj, I guess we'll call it, is going to be this. So in reality, I'm going to say like rename to num cells xy here, but we'll leave width and height there for now, which means that we don't have to do these calculations here. And then instead of doing mod, we're doing some sort of like flooring division. I think. No. Because we might be negative, right? The like coordinate space is going to be like, this is 0. Everything to the left and down is negative. Everything to the right and up is positive, right? So if we just do like x position divided by cell position, we're going to have a problem. So I guess we want to like find like our distance from the left edge. So this is going to be like total like obj width is 2. It's always 2, right? Negative 1 to 1. So our x cell, XL, is going to be point plus 1? Yes. Point, the x position plus 1 over the width in object space. And we're going to do int from float here to floor it to a usize. Yeah. Okay. Then the y cell, we just do the same thing with 1. And then I guess we're just like, we look at our self, which is our erase lookup, and we do self cells at y cell times width plus x cell. Append. We append this guy. Yeah, we append this guy. So this is going to be like stroke ID and point ID. Yeah, okay. That seems reasonable. So far. Arsty Arston, thank you for answering everybody's chat questions for me. So that I don't have to. Okay, sure. So this will put them all in there. And I guess before we do this, we have to clear them all. So I think if we're resetting this thing, it means that like all of these array lists need to clear their memory, which kind of is annoying a little bit. It might be nicer if we could just nuke all allocations, like all sub allocations of this guy completely. So let's do that. Let's do that. This guy's going to take in a, sphallicator. Then we are going to initialize our cells probably with this arena. And then we're going to store we're going to make a sub allocator. We'll call this like cell content alloc is going to be a sub allocator named like erase lookup. Yeah. And then this guy gets named like this. And then we can just nuke all memory associated with these things. We can do something like this. And then we can memset cells back to empty. And then we just use this everywhere. Okay. Yeah. There we go. There we go. Okay, so now we just have to make it so that when we change which object we're looking at, we reset the erase buffer. So who changes this thing? So does anybody change that thing? Surely, like when I click on something in the UI, somebody's asking us to set selected object. Surely there's some like UI action. Update selected object, yeah. That says set selected object here. And so here, we should just reset the erase buffer. If selected object as drawing, we reset with this thing now. Yeah. Yeah. And we can kind of see what that looks like now. He does not compile because wherever the fuck I was constructing the erase lookup, I was using the wrong allocator. This guy just wants my allocator type now. Cool. Area union is ignored on reset. Here, which means that this guy can fail now, or yeah, I guess he can. Not that he ever will. Oh, that's gonna be fucking annoying. But it's fine. Alright, looks like we're good. Object zig 674 is pissed because area union is ignored here. True. Area union is ignored on these as well. Blomp, blomp, blomp. Okay, there we go. Double try. Oops, I'm a dumbass. All right. So I guess, what do we expect to see here? We expect that if we make a drawing and we swap to it, we should see our erase buffer fill up with stuff. So if I go here and then back, I should see a spike in erase lookup memory usage. Nice, which we do see. And then if I draw some more stuff on here, and then I swap here and back, we should see that go up some more, which we do. We see like every time we're getting like more stuff in the buffer. And then if I make another drawing, we should see that the erase lookup shoots down to 0. Nice. And then if I start drawing in blue on this guy, our erase lookup he does not populate data as we draw, only when we switch. So I switch here, he shoots back up, and then I go here, and he should shoot back down to something a little smaller. Seems kind of reasonable. Seems like it's kind of working. I'm a little concerned about like the cost of this thing. Like this being like 17 kilobytes is like, that's a lot of data. I bet that we're probably putting too much content into these strokes. If I were to guess, I would guess that we are probably like, I bet you we've got like lots of points that are stacked on top of each other. I would bet. I think probably what we should do is if we check on when we add samples to our drawing object, we should check if the last stroke. Yeah, we just unconsciously add this thing. I would be curious to see how often we're just like appending the same point. So we probably want some like distance threshold, and we want to say like if point is like point minus last point. So we can say like last point is self if self points last or null. If these guys are like close to each other, so like last point minus point length is less than like I don't know. Like if he's like really small, can we like reject this? I wonder if this will reduce memory usage by a metric fuck ton. And by a metric fuck ton, I don't actually mean a metric fuck ton, but like, you know, a reasonable amount. So I go in here, I like draw. Like, does that have any effect? Not really. I guess because we are like moving the mouse a lot. Can we like calculate like average distance between these guys? Maybe it's fine. Maybe we just don't think about it for now. Let's not think about it for now. Let's just undo this and put like a fix me like deduplicate points. But maybe it's fine. Okay, maybe we try to actually. We need to like add points to the grid as well. So that comes from like position here, add sample from position, add stroke. So who calls these? Why are these different? Add draw stroke and add stroke sample. Why are these different? Oh, because when the mouse is clicked, it knows that it's a new stroke. Otherwise, we just append to the last one. Sure. So on both of these guys, I guess we should be like appending to the erase buffer. And it looks like we can just shove pause in there. Except we need to know the stroke ID for that thing. So maybe this sample, these guys will return their like ID drawing index, which I guess will then come out. So these guys return what they put in. So like this and like this. And I guess that these are really simple to export. It's like literally just like stroke ID is self strokes len -1. And the point ID is self strokes items at self strokes item at like stroke ID. So the last thing it's like this. Something like that, where we have like the last point and the last stroke. Let's return those from both of these. So appended, like, new point is these. And these get inserted into the erase lookup. So we say, this position has this point. Yeah, fuck it. Something like that. So it was position and ID. Yeah. And so I guess this just does this again. Boom. Right? I think we just write ID in here. Which means that, like, surely this guy can just call, like, self append here with the point and, like, the ID like this. Yeah. Yeah. Cool. Cool. He's pissed off. Where? Unused local object? Are you high? He's used right here. Oh, okay. Here it's not though, so add stroke. Okay. And then these guys have to be tried because they can fail. Okay. So now I guess as we draw these things, we don't really know like the validity of them at all, but we should see that they're like going up as we draw. So now we shouldn't have to like toggle back and forth. We should see now that the erase lookup here is growing as we draw. Yep, okay. Again, maybe this is too much memory used, but at least we're seeing some evidence of something happening. Which is cool. Okay. So now what? I guess we've added points, and can we try removing them now? So can we maybe at first, let's just like make it so that when we right click on a drawing, that like it will emit some sort of event that says, could you try to erase stuff under the point? And then we can try to figure out how many points would be erased. I think that's probably a reasonable first thing to do. So do we have a right click anywhere? We have set right mouse. We have click right mouse. We don't have like mouse down and up on the right mouse. Okay. So it would be nice if you could like hold the right mouse button down and just kind of like slide it around. So I guess we will just replace the existing click right mouse with mouse down. And probably we need to track the click state. Or maybe we like set right mouse down and set right mouse up. How do we handle like the left mouse here? I see, we just like set some internal state. So all of the, I see. So we would like set our internal state on right click. We have drawing mouse down. Huh, that's not what I'm looking for. Where was that like transform thing? Composition input state. Input action. Am I high? Set mouse down. Oh, I see. I see. So we would probably just do like right mouse down here in the drawing. And then we replace the existing right mouse click thing. We replace that with right mouse down. Yeah. So wherever we click right mouse, we set right down. Okay. And then we have set right up as well. And this is going to call set right up down here. And he might have some input action, but he probably doesn't. Probably. Okay. So click right mouse is now set right down. And if we are in a drawing, all we have to do is say the right mouse is down. And then on right mouse up, we need to release that thing. So it's really like, are we in drawing state? And if we are in drawing, then we set D right mouse down equal false. Okay. That seems reasonable. Then presumably when we move the mouse, that is when we try to delete points. So set mouse position, we now check our drawing state and we say else if D right mouse down. Here we say please do some action, which is going to be remove stroke samples at this position. That seems hype. Remove stroke samples. Cool. That seems kind of reasonable. So now, whoever was calling like click right mouse now is going to be pissed off, but also this guy needs to actually remove the stroke samples. So for now, can we in here just like look up how many points are at that point? I think that's what we're going to do. I'm going to put unreachable here now so that we can remember. But I would like to start by just seeing how many points are under the mouse as we erase. But we need to compile to that. So set right mouse down. Everywhere that was like click right mouse, we're going to set right down, set right up, I guess. In the linter script that's trying to like just hammer the app and make sure that everything is right. I don't think set right up can fail, actually. So he shouldn't be failing here. Okay. How mad is he still? Okay. On set right down, we do have to return an action, which means that after we set this thing down, we also have to say, like, remove stroke points. I think that also makes sense. What do we call it? Remove stroke. What do we call it? Remove stroke points? Remove stroke samples. Of course. Of course. That's what we called it. This guy's mad because we called. So on right mouse press, we set right down. And how do we set middle up? We have middle release and mouse release. Do we have right released? No, but we can make that. So whoever identifies, so this guy has to say mouse right released, he needs to reset him, and whoever identifies right mouse pressed needs to keep track of this stuff. Which means that somebody here has right click as a window action. This should be right down and right up, which means that probably our window manager abstraction needs to be aware of this thing. And I love it when you just like hit compile, it just tells you exactly what to do. Seems reasonable. Seems reasonable to me. That compiles. Did we ever call set right up in like the app widget? We need to do if mouse right released set right up. All right. Yeah, this can't fail. True. All right. So we should see now that like when we right click on a drawing that we hit unreachable because he's trying to do that thing that we didn't do yet. So here, let's just try to print how many elements are at that position. So can we go like self erase lookup? We need to do like some form of lookup here. So let's do like get cell is going to, you know, take on ourselves and a point and return the array list associated with that thing. Maybe we just, yeah, I think we want the array list of, what is it, drawing index? Yep. So this is literally just all of this stuff. But he's going to return here instead. And then this guy is just going to call self get cell at point and append like this. So that means that now externally, we should be able to be like, okay, let's get the cell at this position. And can we then do something with that? Let's just print erasing this many points. I think that's like a good initial thing to do. Hi, I'm new. Hello. Let's just start there and see what happens. So we should see that like as we delete initially, we should see a bunch of zeros. Yeah, that makes sense. And then if I start drawing something here, he's saying 26. What I consider to be too early. Also, I feel like this should be spamming way more. Should this not be happening on mouse move? What's going on there? Remove stroke samples should happen if the right mouse is down. I'm concerned that like our this is not triggering correctly. So if button is right and is down, or okay, so this feels like it's right. What about an app widget? We have mouse right released. And set right down. That seems kind of reasonable. Right up is setting released. Yeah, I'm a little confused. Can we print here? Right down and right up and like kind of see how that's... Are these guys identifying themselves at the correct times? Oh, right up is getting triggered like non-fucking stop, which is fine because this is cheap. Okay, so that means that it's like on mouse move. I feel like this must not be doing the right thing then. Like, surely this should be like fucking spammy. Oh, he is. Maybe he's not? The fuck? It felt like it was spamming until there was stuff there. Right? Like, that feels like it's spamming good. Why is this not happening? What is happening? What is the, like, symptoms here? It feels like it's after the first release. Ah, I'm forgetting to... I see. I'm not resetting the release flag on every frame, which was causing it to behave stupid. Okay. There we go. Okay. So now we draw some stuff. And this feels like totally fucking wrong, right? Like, this should only be removing points when, like, my cursor is over something, which is clearly not happening. Clearly not. So let's just double check again. Technical sophistication in the streets, foreground, spamming baby and sheets, background. So I draw this all the way up here, and this all says 0 until... It's doing something brain dead here. It's like working in like 4 quadrants. What do we call this object? Zig is where this thing lives. So Y cell. So this is going to be something between 0 and 2. And I'm going to be dividing that by some really small number. Can we like cell ID this? This is going to be like... Like, are we doing something like brain dead here? Yes. We are very clearly doing something stupid. There are 4 cells here. Okay. So... Why? So this is going to be... I'm literally only getting 49 and 50. Right, because this is... Oh, this should be times width here at the end. Yeah. Yeah. No, because these are 49 and 50. Right, because I'm always getting halfway. What unit is all this shit in? Am I fucking stupid? I guess we need to write some more stuff down. Let's just only look at X. So we'll log x cell 0.0 and width obj. Like, what am I fucking missing here? I'm doing something brain dead. I just don't know what. So this guy's going -1 to 1 as expected. We have each cell is 0.02 in that range. Also makes sense. So 1 over 0.02 should give me 50. And then -1. Yeah, okay, so that makes sense. So 2 over 0.02 should give me 100. Yeah. 2 over 0.02 gives me 100. That makes sense. So my point plus 1. Oh, I didn't write brackets. I'm a dumb fuck. I'm a dumb fuck. Oopies. Dude, fucking order of operations. Okay, there we go. So now we have a bug where we need to clamp these guys because the point can actually go out of range. So if point is greater than 1.0, if the point is like out of bounds, or 0.0 is less than -1.0, we have to like clamp this shit. So we kind of do the same thing for y. Which means that this is optional. Okay. If we have some cell or else return, and then like we'll put a fix me on here that's like short circuit on reset question mark, maybe not, maybe we should like clamp, not really sure. All right, okay, if this, then we print how many points we're racing. And does that work a little bit better? So now I draw in here 3, we were like kind of seeing like 3 points on a lot of these. This seems a lot more reasonable. So we're seeing like that thing kind of flicker from like 0 to 4 based off of which cell I'm hitting, which is like pretty hype. Pretty hype. Seems to be behaving as I would expect. Okay. Cool. Cool. Now, what? I guess we actually have to do the erase. So for each point, we need to do like, we need to get the object as a drawing. This is ugly, but we'll come back to it. We must have to do like remove point. Okay. Which means that now we just need to have, you know, remove. And what does the guy take? He takes in a drawing index. Drawing index. So what? He has like, he looks at the strokes at ID stroke ID. And I guess he looks at the points And he probably does like ordered remove, I guess, at point ID. Now, this is going to be actually a problem because all of the IDs will shuffle if we do this, which is kind of fucked. So when we split this thing, we actually have to regenerate the whole erase buffer because he's going to be like holding a bunch of invalid IDs, which I guess is kind of like fucking fine. So we're actually going to, like if it's fast enough, and it probably is. We don't have to get too fancy. I'm sure there's like better ways to track this stuff for now. But for now, I think this is fine. So maybe we make a new stroke. So we get like the existing stroke. We take the stuff from the point ID onwards. But only if this thing fits. So we go like, so like the new stroke is going to be like kind of like the right half of the stroke. Everything after the point that we removed, he gets put somewhere, right? So we probably handle this differently if we're on the left edge or right edge of a stroke. Probably. Hmm. I don't know how I want to do this because it would be nice if we're removing like many points at once. Maybe we just like shove some nulls in there or something, or maybe we like sort all of the removed points. Yeah, I think that's the play. I think we just like completely fucking regenerate everything. Yeah. So we're gonna be removing like, well, how many points are we seeing in this thing? Like 3? Right? We were seeing like 3 points in here. So there's not like a lot of stuff going on in an individual frame of erasing. So that's an important thing to think about. We're going to remove maybe like 10 points. Maybe. So as we remove those points, it's possible that like the stroke becomes empty. That's a very real possibility. So we will, yeah, I guess that's fine. So we will try to split this. All we're trying to do is split the stroke in half. What language is that? This is Zig. So if I guess we get the stroke, this thing we should be fairly confident in. We have the point is right half is going to be like if the point ID is less than stroke dot points items dot len or something. If this is true, then we're going to look at stroke points items from ID point +1 onwards, which means that this has to actually be +1 here. Otherwise, we give them an empty array. Then we just truncate this guy. So we just resize him down to be this long. And it looks like this guy... Can we like resize assuming shrink and free? Ooh, I like that. Shrink and free. Do we not have an allocator here? Wow, we don't? What the fuck? Okay. That's weird. I'm not gonna really think too hard about this right now. But we shrink and free this guy with this. Then we create a new stroke. Given the rest of the stuff. If right half len is greater than 0, we, do something like this. And we say stroke. The last stroke. I don't know, man. We append slice of the right half. Surely. Surely this does what I want. Okay. So now this remove needs to use, like, I guess, selected object allocator, I guess is where this comes from. Ew. Gross. And then after all of this thing can fail because of clear and free, which means this has to be tried. And then after all of this, we have to regenerate the erase lookup. And before we do that, we should probably try to, like, clear empty strokes. Because, like, some of these may have ended up being empty at the end. So I guess we're gonna be like, for 0 to self, for each, I think we work backwards if we're trying to pop stuff. Yeah. So this is like self strokes items len. We go backwards and we say, while idx is greater than 0, we index minus equals 1, and if this is an empty stroke, I don't know, we swap remove it, like, and probably free this guy. Can we just do like this? Self strokes swap remove index. Okay. Does this give me the thing back? He does. And then we must have to, like, deinit this guy. Looks like that doesn't exist. We'll just do it manually for now. All of this is kind of gross. I'm not really a big fan of the vast majority of what I'm writing right now, but I think it'll work. Okay. Yeah, I think that's fine. So then we clear empty strokes, and then surely we have to, like, regenerate the image. Because, like, we'll have removed points. So, like, we have to regenerate. Yeah, so we just call generate distance field again at the end of all this, I guess. Okay. Seems like it's something like this. Self renderer distance field renderer. Sure. I don't know, man. That seems like it could work. No point. There we go. Expected type something found something else. What's he pissed about? What the fuck? Oh, because it's constant? Because I didn't put an ampersand on here? I guess. Air unit is ignored. True. And then this guy's pissed because he expected a slice of vector 2's and he found a slice of vector 2's aligned 1. Why is it aligned 1? The fuck? Where is this coming from? Right half. I feel stupid. Alignment 1 cannot cast into pointer alignment 8. Append slice. Oh, is it because of this? Can we just specify that this has to be 2 aligned? Surely. That's a weird kind of strange little thing. But I guess it is what it is. Generate distance field needs to be tried. This needs to be tried. And if any of these things fail, like, do we need to worry about, like, consistency in here in any way? Probably. Like, I'm just gonna put, like, a big fix me on here and just, like, error, consistency, the whole way down. Like, what the fuck happens if we like fail to allocate some strokes? Do we just lose them? Like, what are we supposed to do? I don't know. Okay. So now I can, like, crash. Memcopy arguments alias. Oh, I guess this is dangerous. Because this is going to be a reference to stuff in the points. Then this will be fine. No, this will still point to the same memory. Oh, but this shrink and free can't happen until after. We're lucky that they aliased. I think what happened is, like, we shrunk one array and then allocated another array that happened to fill the same space. Unreachable code here. On shrink and free, new len is less than or equal self items len. Okay, so what's going on there? This is now also invalid? God damn it, dude. You have to be so fucking careful with this shit. That's so fucking annoying. That's so fucking annoying. I'm glad that it's, like, crashing as hard as it is, because, like, we could have been really, like, out to lunch here. That's still not working. Now I'm a little more confused. So we're saying I almost always use indices. Yeah, but I was just trying to, like, give this, like, shit show of a sentence, like, a name, which is, I guess, not doable. Unless we do it like this. Then at least it's a little better here. Okay, but then, like, why is this still not working? So ID, point ID, he's failing an assertion that this is less than or equal to items len. So I guess can we just run this in GDB and see what the fuck it's complaining about? Because I feel like that shouldn't be happening. Okay, so we're like in here. We right click over here, nothing happens. We right click on something. Okay, he crashes. What's happening? So we go up to frame 8. And we have ID. So we're like stroke 1.2. Okay. So can we look at like self-strokes items pointer 1. Okay. So our point ID is 2, his length is 1, capacity 1. So that is kind of a little confusing. Oh, fuck. Because we've already removed a point. Oh, fuck me. Oh, that's so annoying. So what's happening here is like we have like 3 points in this box. When we delete one of them, the guys on the right side like move. The guys on the right side move to a new stroke ID. Right? So like if we delete this guy becomes part of a new stroke. This guy stays part of the old stroke, which means that we have to do them in like reverse order. Yes. So we actually want to do something like batch by stroke, then sort within a stroke and do it backwards. Or we could just sort by stroke, then point, and then go backwards from the end. And that should work. Okay. So instead of this being like get cell, can we call this like get like get points in cell? So what we're going to do here is we're going to allocate a new thing and return it back. So this guy's going to take some sort of like, allocator to allocate with. And we're going to be like, we're going to call like get cell at point. And this thing can fail. So in this case, we'll return empty. Then we're going to be like, copy these things over. So this is just going to be like a duplicate of cell items. Like this. And just before we do that, we'll sort them. So I think it's like this, and we're sorting drawing indexes, and we're sorting our return. And we have a context, which is nothing, a void context, and then we need a less than function. So we need to define how these things are going to be sorted, which we can just do inline, I think. So context is void in this context. LHS is a drawing index. RHS is a drawing index. Okay. And we just say like, if LHS stroke ID is less than RHS stroke ID, return true. I guess it's like if they're equal. If they're not equal, return this. But if they are equal, then we fall back on the point ID. Yeah. Okay, cool. So then when we like try to iterate these things, we say get points in cell. And I think we actually should just reverse the sort order. So can we, this thing can fail. Can we actually like go the other way? Then we can just run it forwards. And it should be fine. Let's also like just print the points in the order that we're trying to remove them, just to be sure. Okay. Let's see how that plays out. So we draw some stuff, we go here, and we just remove. Oh! 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 Guys! It works! Look at that! Oh, baby! Let's go! Let's go! Okay, so there's also a problem where, I think if I move too fast, some of them will be missed. So we're gonna have to implement like eraser sizing, as well as what we actually should do. Actually, we can actually draw it here now. We need to calculate like for each mouse position, we need to calculate like the vector that this goes through, and we have to clear all cells in that list, right, for this to work. And then I think that you can see it's like pretty clearly fucked. And then we also need to add like an eraser size to basically say how many grids, how many cells around the mouse we're willing to look at, which makes me think maybe this becomes like a like tool that we click on. But at the very least, it's somewhat usable. Somewhat. As long as we keep the drawing small, then we can start using this, which is kind of hype. Kind of hype. Let's go. Okay, that's 350. So I think I call it there for today. We made some good progress. It would be nice if, you know, it worked a little better. But I think that this just means that there's like a day 2. So yeah, what do we say we have to do? It's like, I just tried to undo, which doesn't work. So it's vector between points, between mouse samples. And the other thing was size. So I don't know if that's enough for a full stream. I think that's probably pretty straightforward. So that's probably going to be a happy hour task, or maybe even off stream. But otherwise, I think it's pretty good. So cool. Thanks for watching, guys. If you liked what you saw, we stream most days around 12:30 Pacific time to 4 o'clock Pacific time. It is 3:50 Pacific time now. So anywhere between 3.5 hours ago and now is when you should expect to see us live. If you like what you saw, you can, but you can't watch all the time. There's YouTube. There's VODs of the like 12 or the 2 to 4 segment on YouTube, posted whenever we make them. There's another segment which we call Happy Hour 12:32 or 12:32. Yeah, 12:32, and that's kind of just like stuff that I don't think is like titleable and thumbnailable very well, but kind of just like, you know, stuff we got to work on. Maybe not worth making a whole video out of, but worth doing anyways. If you want to support, consider the fact that, you know, this content will end someday. I'm making way less than I would make as like a real software developer. But every dollar that I make doing this delays that day a little more. So if you want access to VODs of the Happy Hour segment, please consider contributing or supporting on Patreon, YouTube, or Twitch. I think that's all we got to plug. YouTube, peace out, and Twitch, let's find someone to raid.